Welcome back to part 2 on dividing polynomials. We're now going to move into synthetic division, and for those of you who have never seen it before, you're going to be so excited because it's so much easier than what we were doing in part 1. For those of you who have seen it before, you probably already know what I'm going to show you. Synthetic division can be used when the divisor is in the form of x minus c. Notice that synthetic division is not something you can use for something where you have like an x squared minus 3x plus 2. That's not in this form. It needs to be in binomial form. So we have a divisor, x minus 1, and I'll write that again right here. From our rules of zeros of a polynomial, we know that the root, c, would be 1. So I'm going to write this in a little, two-sided box here. And then because when we are doing polynomial long division, we are using the coefficients and the fact that the terms are always in descending order to list the coefficients off. So x cubed has a coefficient of 1, x to the second has a coefficient of 0, x to the first has a coefficient of 0, and x to the 0 power, or just the constant term, is negative 1. This means that I now have a descending order of coefficients, and it's understood that this is my c, this is x to the first term, this is x to the second term, and this is x to the third term. So when you're trying to decide what your quotient is, you always work your way from right to left, every term increasing by one exponent. The first step in this process is to drop the first coefficient, the highest degree coefficient, down below the line. Then I take the number that was from the divisor and I multiply it to the 1. 1 times 1 is 1, and I put it below the next term to the right. Then I add 0 plus 1, and I drop it down. Then I multiply 1 to the next coefficient that I just dropped down. This gives me 1 again, and I put it below the next term to the right. I add 0 plus 1, and I put it below the line. 0 plus 1 is 1, and I multiply it to the root, or the 0. 1 times 1 is 1, and I put it in the next column to the right. Negative 1 plus 1 is 0, and so my remainder is 0. So let's recap. We had a remainder of 0. That's my remainder. We had 3 other coefficients. Let's work from right to left and assign degrees to each term. This is my c, my constant term. This is my x to the first term, and this is my x to the second term, working from right to left. This is just to be very sure that what I've assigned as the different degrees is actually accurate. So my quotient is x squared plus x plus 1. We could also write this as x to the third minus 1 divided by x minus 1 is equal to x squared plus x plus 1. Let's try one that's a little more tricky. We've got x plus 3 as the divisor. That means my 0 would be negative 3. Listing from highest to lowest degree, I have x to the fourth with a coefficient of 1, x to the third with a coefficient of 0, x to the second with a coefficient of negative 10, x to the first with a coefficient of negative 2, and x to the 0, or the constant term, just the number 4. Now I drop the first term's coefficient down, which is a 1, multiply -3 to 1, which will give me -3. Add that to 0. That gives me a -3. -3 times -3 is +9. Adding -10 and 9 together, we get -1. -3 times -1 is +3. Put that in the next column to the right. Add -2 and 3 together, and we get +1. Multiplying -3 to 1, we get -3. Adding 4 to -3, we get 1. So my remainder is 1. I could write this in several different ways, but what I will do is I will write this as x to the 4th minus 10x squared minus 2x plus 4 divided by x plus 3 is equal to, now this is my constant, this is my x to the first term, this is my x to the second term, and this is my x to the third term. So each one of these numbers directly above it is the coefficient that is assigned to each one of these terms. This is equivalent to x to the third minus 3x squared minus x plus 1 with a remainder of 1 over x plus 3. This takes a little bit of practice, but once you do a few of these, you can really get fast at synthetic division. This is one thing I really like about synthetic division. If the remainder is 0, you have found a 0 of the polynomial, and if there is a remainder, you'll need to try a new one.